Hi, everybody. My name is Arben Kalzici. I'm with the Wolfram U team. I'm just introducing today's webinar, which is about programmatic access to LLMs in Wolfram Language. So there are a few housekeeping things to get out of the way. The first is that you should grab this notebook that's listed as a resource notebook. If you get that, you'll be able to have this notebook that you see on the screen here. And this has a bunch of useful resources for this week's webinars, as well as just using LLMs and Wolfram more generally. You can grab a trial in case you don't have site access. You can check out our Wolfram Tools for AI link. You can get all the notebooks for these webinars here at this link. And you can watch recordings because all of these webinars will be recorded. So today's, tomorrow's, and Thursdays, you'll get a link to those recordings in your email, but you can also get this link here. There's information about LLM functionality in the general case in Wolfram Language, as well as quite a few other things that we'll be talking about throughout the rest of the week. I don't want to go through and just read every single thing here since we'll be talking about all these things, but suffice it to say that this is a useful notebook that you should grab. One thing I would like to mention here is that in order to use LLM functionality in Wolfram Language, we will be building that into our version 13.3 release, which is coming out later this week. But if you're on the current release, which you are, hopefully, if you're not a Wolfram employee already and have early access to the new release, you will need to install a Packlet in order to do that. The link to do that is right here in this notebook. And I just wanted to push out a poll to see who is perhaps using the most recent version and who might already have the Packlet installed. I know it's fairly rare for us to need to install Packlets here in Wolfram Language, but for new functionality, kind of cutting edge, we're getting that stuff linked in here just before official release. Now, the next thing you do need, and you'll need to do this in 13.3 as well, is you will need to have access to an API key, either for OpenAI or for some other LLM. So I wanted to check whether folks had access to such an API key already. And again, this is a fairly simple thing. I can't guarantee that it's quite as simple as installing the Packlet, but I believe it just involves going to the OpenAI website, making an account, and you'll be granted an API key that you can use. So yeah, for anybody just joining us in the last minute or two, I've mentioned that in order to use LLM functionality in Wolfram Language, in order to access it programmatically as you do anything else in the notebook, you will need to either be on the currently unreleased 13.3 or download a Packlet, which is linked in the chat if you're on the current newest version 13.2. Then you'll need to make an account with OpenAI or another LLM provider, and you can grab an API key, which you can use in conjunction with that Packlet to access LLM functionality in Wolfram Language. And just to give the absolute briefest preview, what I mean by saying access LLM functionality in Wolfram Language, I keep saying it like that. What I mean is you'll be able to type things like LLM function, and you'll have some kind of template for a prompt here, like how fast is a, and then you can have some blank entry here, and then this could take, say, cheetah. And then you would run this, and it would, use the LLM that you have signed up with and have an API for in order to answer this kind of question. Well, now it's a question, if I can type correctly. And because this is a fully symbolic, Wolfram Language thing, you could say, speed knower is equal to this LLM function, and then you can do things like speed knower on, cheetah, boar, Ford Mustang, these sorts of things, because it's just a fully symbolic object. But I don't want to get into the details of this. That's the job of today's presenter, Jofre Espigule-Pons, who is a research scientist on our machine learning team. So I'll go ahead and pass things over to him to get started with the actual details of programmatic access to LLMs in Wolfram Language.
Thank you, Erwin. And no worries for the pronunciation. It's a Catalan name. So I will start sharing my screen. And I guess since I'm at dorm at the Wolfram Summer School at Penn University, I will switch off my camera to be able to be sure that the connection is good enough. As Erwin already mentioned, if you have like 13.2, you need to install the LLM functions packlet repository. You have the links, but I can show you briefly how does it look, the packlet repository for the LLM functions. And here there are like several functions that I will discuss today on this presentation. Basically, it's a programmatic access to large language models using the Wolfram language. And I think tomorrow Bob is gonna talk about the Wolfram prompt repository and how to access different types of prompts, like personas and modifiers and function prompts. And I think on Thursday, Theodore is going to present the functionality of chat notebooks. So here it's going to be more low-level LLM functions for today. So the programmatic ChatObject and ChatEvaluate would be the kind of the low-level programmatic foundation for the chat notebook. One thing I wanted to mention before going to that is, if you install this week the 13.2, the 13.3 and onwards, it's gonna already be built in all these functions. Otherwise, you need to packlet install these LLM functions. And also worth noting is some of these examples I'm going to use for today. They are taken from Steven's Wolfram blog post on these new LLM functions. So I also provided a link here. And so let's start with the chat functions. So for example, chat object with empty arguments, it's going to give you a chat object that hasn't started with empty chat, and from there you can, for example, start a conversation with a default OpenAI model, which here is the ChatGPT one, which is like GPT 3.5 Turbo. And it's a way to programmatically have a chat with a LLM. In this case, you can go back and forth. And also, if you are interested into the chat object structure, you can get the messages, which will have a list of associations with the different role, the content, and also the timestamp. A nice feature is that one can also check how many tokens were used during the chat conversation. So there's a kind of at the end, if you spend more tokens, which are like pieces of text that are sent to the LLM, and in the case of the OpenAI models, it's kind of, I think it will cost more if you are like using more tokens. Right. In ChatEvaluate, one can also use the like LLM prompts from the prompt repository, which I will not go into the detail for today. But for example, in this case, there is one prompt called Yoda, so we can ask to have ask a question using this pre-prompt or prompt. Yeah. Another cool thing to do is that one can use some built-in functions like nest and iteratively let the AI or the LLM interrogate itself. And in this case, I think it took several seconds, but yeah, here there's like a conversation with itself using nest, iterating it 5 times. Yeah, be careful on these kind of loop functions or nest and while, because you can run out of OpenAI credits or like spend a few, like a bunch of money if you iterate, if you don't set up a proper iteration. So one of the first functions I'm also going to talk is the LLMSynthesize. Basically, it's an evaluator for the LLM. It will run, in this case, by default, the GPT 3.5 Turbo, but one can specify also other models using the LLM evaluator. I think by default, the LLMSynthesize has a temperature of 0.7, so it always will return different outputs if you evaluate the same prompt. But the cool thing is that one can specify the LLM evaluator and also kind of have an LLM set up an LLM configuration. So in this case, I'm using a prompt for like talk like a parrot, and yeah, this is the difference. So I haven't not evaluated this. Right now, we only have the option for OpenAI models, but we plan to also incorporate the option of using other LLMs like Cloud or BART from Google, and potentially in the future also to be able to run our kind of your own local LLMs to be able to be used within these functions. But for the moment, we have to use these OpenAI models. I think by default, so as Arvin already mentioned, that you will need to kind of set up your OpenAI API keys. And then one thing one can do is in LLMSynthesize, one can specify the LLM evaluator, and that would be like a way to programmatically always have a default prompt before the kind of the prompt input that you're going to use. In this case, is like I'm asking it to always answer in French and give just the answer to the questions without being verbose. One other parameter that one can specify in LLM evaluator are the stop tokens. In this case, I'm asking a list of animals, but whenever it encounters the token $F, it should stop generating more tokens. And that's what happened here. I think, one can also specify directly the LLM configuration outside the LLMSynthesize and be able to use it afterwards. An important parameter as well that one can use, that users can use inside the LLM evaluator, is the temperature. So temperature is and like lower temperatures tend to have like a more predictable output. So also for example, if you're planning to do some coding, like the LLM to generate some code, I tend to use temperatures close to 0. So since I can then reproduce the results more often. Theoretically, temperature 0 would mean that the large language model is always picking up the same tokens. In practicality, there's like some GPU technical issues that are making the results even different at temperature 0. But yeah, if one goes to temperature 1, the text can be quite creative. But above certain threshold of the temperature, like I think it's around like 1.2, for example, in this case, I was testing this with temperature 2, and you can see that the kind of the LLM brain melts down, and it's a bit of nonsense. So temperature is it's a cool feature to also explore. So here I'm gonna start with the LLM function. That's, I think Erwin already showed a small example on LLM function. In this case, I will start with like a simple example of like rewrite inactive voice, and this would be like the string template slot. And basically, LLM function is a template object, so we can do input form. And we'll see that inside that template object there is the prompt plus the template slot, and plus specifications on how you are going to combine the text within the prompt. And now we can evaluate this LLM function, and here we get the sentence inactive voice. Another example is that one can specify multiple arguments within the template of the LLM function. In this case, to find several word analogies. I think it should work well. Yeah, and as well as like applying list to it, like finding the opposite of words. Another cool feature of the LLM function is that one can change the default interpreter. So right now, the default interpreter is a string, so it interprets the output that the generated tokens from the LLM are converted into strings. But one can interpret the results using the second argument and specifying which type of interpreter to be used. In this case, we want to interpret the output as colors, and it will interpret the orange as the RGB color. The same can be done for other type of entities. In this case, like finding entities for cities. Let's see if I'm running it again. I will get a different city, but no. Other interpreters that I found like cool to be able to use directly with LLM function is you can ask the LLM to generate like certain kind of topic, to generate like a JSON file, and then we interpreted the JSON, so it will give you a list of key values. The same for so in this case, I'm going to introduce the LLM prompt as well. So this is from the prompt repository. You can find multiple useful prompts. I'm not going to go into the detail because Bob tomorrow is going to explain a bit more on how to use such prompts. But basically, you can combine inside the LLM function as a list different prompts. The default prompt from explain me like I'm 5, and then your question. And here it explains how far away is Mars from Earth, and as you are a 5 years old child. Another thing is that inside the LLM function, one can specify a specific specify a function to interpret the output. So not just using interpreter, a type of interpreter, but a specific expression, Wolfram language expression. In this case, I'm asking it to the LLM to output the results as a list of associations. And then the interpreter function I'm using, it's going to be the following. So it will interpret the output as colors, and it's going to be giving me the most fashionable colors in a certain year. And I think that should work. It might take a few seconds. I think in the early 1990s, the colors were like purple and I think violet and other. It's taking too long. Maybe that's part of the live coding. Hopefully, OpenAI API is working right now. Okay, So there's a service issue. Okay, second try. And we could modify it, and I don't know, in the 60s. We should get different colors. And another example, but in this case, I'm trying to obtain directly, interpret the US presidents from a certain period of years, and also ask for the initial date of the president and the final date, and then using this interpreter function to obtain directly kind of a nice looking structure data. We could, yeah. So it will interpret them as person entities, and then these are going to be already like date objects that can be used for other applications. So I think it's a good way, this LLM function to extract unstructured data or explore what these LLMs know about the world. And this was another kind of nice application of LLMs. In this case, what I was doing is to try to extract questions from a script. In this case, the test was, and I think an interview of Stephen Wolfram with Lex Friedman. What I did is to go to the YouTube channel, and then I think there is the option to get the automatic transcription of the interview. And as you can see here, there is no punctuation marks or question marks. So it would be cool that the LLM can do the job for us and select and extract from there the questions that were present in this interview. So this would be like zero-shot learning. I'm not giving an example specifically, but I'm asking it, okay, so here we will insert the text or the transcript, and the output that I want, it's a list of questions extracted in this format. So this is going to be a list of strings. And then I'm creating the template slot as name it as text. And finally, I'm adding the output. So by this idea, you get a more structured output from the LLM. In this case, I was using GPT-4 for better results. One thing to note is that if you don't have the OpenAI Pro account, I think there is limited access to GPT-4. For experiments, I always recommend to start with GPT 3.5 since Turbo, since it's much cheaper, and you will be able to have a guess, to be able to experiment and try different prompts before kind of switching to GPT-4, which is more powerful but also more expensive. Another function is the LLMExampleFunction. This would be the behind the scenes it's the same as LLM function. So it's also a template object, but in a specific kind of format. You can see that there's like multiple inputs and outputs. That this would be like the examples. Use it for the LLM to figure out what's going next. And in this case, it does a good job for this particular problem. That it's just like adding an integer and also. So why this few-shot learning is important. So LLMExampleFunction make use of this capability of large language models. That was kind of some capability that still it's not fully understood how it works. It's in context learning for these LLMs, but it turns out that these large language models are good few-shot learners. Here I'm pointing you out to this research paper studying these few-shot learning capabilities of these big models, especially GPT-3 and GPT 3.5 and GPT-4, they can solve really nice problems and using this few-shot learning technique in prompt engineering. So that's something that you should explore. So I will start with some basic examples. Here I'm giving a bunch of examples on whether a sentence, the main character it's a male or a female, and then I want that the output is just displayed as an M or an F. Of course, I can immediately try to see what happens if the LLM will complain and say that code is not human and that doesn't have a gender. And if we want to go to more sophisticated functions, for example, I did this example for extracting personal data from unstructured text, let's say a Wikipedia article. And in this case, I give like the main prompt would be like replace personally identifiable information in text with Wolfram language and list as a list of association. So, and this would be like the first example I'm giving. So there's a person with some personal data inside, and then the output of this example, I want it to be kind of an association with the keys and the values for this personal data. And with this, the LLM will be able to kind of figure out with only one example. It does already a good job on creating this extracting this personal data from text. In this case, I was testing it with the Wikipedia data article from Alan Turing, which we can directly get with Wikipedia data. And one obtain such data set, which is quite nice to be able to directly get this structured data from unstructured text from Wikipedia or other sources. The same can be done for like anonymizing something. So in this case, what we want is that to create a template that will replace certain personal information and be replaced into template slots in this case. And another example I did was to try to extract like a data set of requested colors in a programmatic way with LLMs. In this case, I was giving several examples, like interesting colors from tribes living in the Amazon. I did a bit of research, and then also the kind of the output of this input example for the future learning. I wanted to output it in a particular structure, and in this case, an association with the color, the name of the color, the phonetic transcription of the color, as well as the description, and if possible, the language that it's using. And from there, I think I was able to create this kind of LLM color dataset function. And yeah, it was working well for like colors from Australian Aboriginal languages. Some of them have to be double checked, but it was interesting to explore colors around the world from data that probably GPT-4 and GPT 3.5 have ingested in their like billions of texts. And I think here I was doing like asking for like 7 interesting colors from ancient Greece, and they were like nice kind of colors that most of them were like used in their daily life, like wine red color and other ones. So, and another nice example or useful example would be like extract events from unstructured text. like dates, or even with the location of the event. In this case, I was using this example in this particular structure. So I would then have this interpreter function to obtain a data set on unstructured text. In this case, I was again using Alan Turing Wikipedia data article, but this should be able to work on other types of events. I think maybe we can do a live experiment here and see if it works. So I will try, for example, let's see. I haven't tried for a while. I did this example several months ago, but it should work. Or it did not pick much, but maybe it's because still, I think this is correct. Another thing that can be used for LLM example functions is to kind of translate or import code from a different language into Wolfram language. In this case, using a MATLAB input code and giving only one example, it kind of the LLM understands well what to do. In this case, the interpreter is like health expression, so I want the expression, but I don't want it to be evaluated. It was doing a good job at least at this simple code example from MATLAB converted into Wolfram language. The same for Python. Even specifying some libraries, one can obtain kind of create a fast Python to Wolfram language converter. And probably if you add extra examples, typically around 10, it is stabilized, but it keeps learning. So in this case, I'm just using 1 or 2 examples for simplicity. The same for like writing Wolfram language code with one shot example. And there's multiple ways of outputting the code. Maybe you're more interested into an evaluated code. You want to check first what was the generated code from the LLM before running it. And that's basically what health expression will do. Or if you are brave, you can directly ask the LLM to kind of generate the code, and then the LLM example function you set up it to be converted the string into an expression, and sometimes we'll just run the code and create a bar chart with random values. It did a good job in this case. More sophisticated examples in this case is starting from a kind of a concept of the big cats, and then getting narrower terms of this word. I was creating this example on creating a graph, specifically a community graph plot as interpreter of this list of key values. So in this case, the LLM will generate automatically a certain kind of community graph on specific topics. In this case, it's like cellular automata, or I think I have like some for like the concept of word and different types of battles. And I think it's a good way to explore the knowledge of these LLMs. I don't know how much time I have left, but I have a few more examples here. In this case was to convert natural language queries into Wolfram Alpha input form. So I asked the LLM with this prompt to directly create such URLs that would be called Wolfram Alpha and display the specific interesting kind of results for a certain topic. In this case, I asked it like, give me questions about the moons of the solar system, and it came up with a bunch of already like working hyperlinks that if one clicks, they can get to the Wolfram Alpha site and obtain. It doesn't work 100% of the time, but it's a nice way to explore more data. The same for this other physics problem solver. Basically, I saw that GPT 3.5 or GPT-4, I don't remember exactly, could not solve this first year college problem, this one here. So I was wondering if instead of asking the LLM to do the calculations and give me the result directly, I could give them one example on how they should kind of try to reformulate the physics problem into a Wolfram language code using quantities. In this case, this is the one-shot example. And I'm asking it, the output would be like this type of expression with quantities. And then using this one, it's able to solve such problems, at least some of them. Of course, I did not do any benchmark on how many of them are solved correctly, but it's a good way to obtain already a solution already in the proper units, quantities. And to end up, I think, well, there's like a couple of things extra to mention here. If you go to the Padlet repository, you will see that there is also this new LLM tool. This is being developed by Christopher Wolfram, and it's a cool way to let the LLM, the large language model, to use some tools, external tools, to do some external computation, and then keep answer you with the result. So in this case, what it's gonna be is like ask for like the specific population using like Wolfram language to get the proper population of a certain city. And this example will make use of this tool call, or the LLM tool. And you can see here now the LLM is not gonna hallucinate and invent certain numbers. Now it's gonna use the proper values from the tool that it's calling. So I think there's a lot of potential there for applications. One other new function that is the ImageSynthesize. Right now, the only model we have is also the OpenAI one, DALL-E 2 in this case, I think. So this function also allows the different, like basically it's a text to image, but it also can be image to image. In this case, it will generate a variation of a certain image that you give. So this is the generated image of the parrot based on the input image. Or you can do some modifications of a certain image. In this case, I was getting the 5 algorithmic default built-in image that we have in the entity store. And then I will remove the background of the mushroom, specifically the right background. And then I asked it the ImageSynthesize to create a mushroom with eyes, and that was the generated result. So other things that one can do is to combine both functions, LLM function or LLM example function, with and then as a second argument to interpret the text generated by the LLM, and to be directly to be used as a prompt for the image synthesize. So in this case, I'm creating this LLM function for generating images, specifying the kind of the animal or entity and the object it's smelling, and also the artist painting it. In this case, is a cat smelling a fish, painted in the style of Dali, Salvador Dali, he's from my hometown, Figueras. I think with this I will finish the presentation, and yeah, I think we're gonna start the question session.
Thank you very much, Jofre. I do have a few questions here. The first is kind of about, let's say, some of the formatting, the way you would actually construct an LLM function to take some input. And I thought this was an interesting question. So let me go ahead and maximize that so that folks can see it. Hopefully you can see it, but also just read it out so that it has been read out. So this person notes, Craig notes, that string template can be called on association. So for example, you can use something like template apply and say first, and then a template slot A and a template slot B. And then you can act that on an association with some named slots, A and B. And Craig is curious if you could do the same thing with LLM functions. So we saw like slots 1 and 2 and things like that, but can you have named slots that act on an association?
Yes, we can. Yeah, I think I have one example I gave with, it was in LLM function here. As you can see, this is an association. In this case, I have a named here the template slot, and this will be able to be called as an association into the LLM function. So I guess it works basically as a template object. Yeah.
Okay, yeah, so it seems to work functionally the same as having some sort of string template or template object.
Yeah.
Okay, that's nice. Always nice to have that kind of intercompatibility there. In this question, I think maybe there's a variant of this question that can be asked. So this question asks about where the LLM computations are being done. So right now, we're using APIs through, say, OpenAI. So what that means is that we are sending our prompts, after they've been formatted appropriately by Wolfram Language in the background, to OpenAI, getting a result and then displaying that result back in the notebook. But you think it's possible in the future that you'll be able to have local copies of these models, maybe reduced in size,
right?
Create your own in the further future. Do you think that's something that might be possible?
Right. Right now it's not possible, but there are plans to be able to do that. The problem is that if you want good LLMs, they tend to be like huge and difficult to run locally on a laptop. But certainly there's going to be ways to kind of, instead of using an API from a private company, to use an API on kind of maybe your own LLM stored in a server like AWS server,
right?
And call that LLM.
Okay, that makes sense.
Yeah, we have plans. We're right now also like training our own LLMs to be able to kind of generate Wolfram language code, but it will take a while before these LLMs reach to the level of the kind of ChatGPT or GPT-4.
Understand.
That's for sure. But yes, I think probably first are going to be other third parties APIs like from Google part, Model, Cloud, and other ones, and then probably we will add this functionality of being able to use your own LLM. Right now, you can also build your own GPT-like model, but with Wolfram language, I have a post on this, like creating your own Shakespearean GPT from scratch. But of course, it doesn't have these few-shot learning capabilities for LLMExampleFunction or LLMFunction.
Okay, that makes sense.
Reasoning on these large language models emerge with the size and how they were like trained, and this is beyond a local computer.
Yeah, certainly currently and for the foreseeable future. Okay, and this is less a question than a comment on a question, but because it's a comment from tomorrow's presenter, Bob Heinrich, I wanted to point it out. And Bob just notes that the convention of using numbered slots rather than sort of the string template slots we were just mentioning is important for using functions in what we're calling chat notebooks. So you can use them in the programmatic sense. You can use the labeled slots, the string template slots that we showed before, as was shown. But if you are using a chat notebook, it seems important that you use or you keep the convention of using numbered slots. I just wanted to bring Bob's comment to the forefront there.
Nice, thanks for the remark.
Let me see, there's some more questions here. Well, there is another question from Craig who asked that question about the string templates, about strategies used to create a prompt, how specific, examples, things like that. I will just note that that will be a big part of tomorrow's talk by the aforementioned Bob Heinrich. So stay tuned tomorrow for more information on that.
Yep.
Look through these questions a bit more here.
A good thing that I did not mention for generating like examples in the LLM example function, something that one can do is to iteratively create like examples with GPT-4 and then obtain the prompt with it. So it's kind of a hand-in-hand work with you and GPT-4 before you find the optimal kind of few-shot learning prompt.
I see. I think this is a reasonable question to ask from Benjamin. These plain text queries to get Wolfram code, does that LLM example function have any additional logic on the Wolfram side, or is it equivalent to querying the model directly?
So the preprocessed output from the model is going to be the same, the token generated by the LLM with a certain prompt. They should be the same in any, so it's kind of cross-platform. It depends on the OpenAI API. But then processing that output, interpreting it as Wolfram language code or creating hyperlinks, that's going to be on the kind of Wolfram side or the Wolfram language side.
Okay.
I'm not sure if that answers the specific question.
I think it does. Let's see. I think this question, I think the answer is likely kind of included in a prior answer of yours, namely that this sort of thing will be coming as we improve our own understanding of LLMs on our end. But this question asks, if we're trying to adapt code generation to work successfully for integrating with Wolfram System Modeler, is there any recommendation on how to get good results there today? Results thus far have produced code snippets that typically do not validate correctly and require a lot of rework to adapt. It is true that I expect System Modeler to be kind of a level above maybe what's possible to get today, but maybe Jofre has,
So have the user tried few-shot learning examples, like to give a bunch of this is an input and an output and a wished output, give several of them, and then this way will be will guide or this in context learning for this LLM to be able to pick up the task much better than just a textual prompt.
Right. And would
That's
you like
my feeling.
Would you like to show an example of that again? I know you showed a few examples, but just to remind folks what that looks like.
So I think let's say, for example, this would be like the input. The first example. Actually, this is only one shot learning example. So in this case, this would be like the input that will be here. This is automatically generated from the LLM example function, the input and kind of semicolons and colons, and then this is the text, and then you can see here next in a new line the output. So this would be like the example of the task that you want to. I'm also giving an extra textual prompt, which is like replace personally identifiable information in the text with Wolfram Language list. But without it, I guess it will also do a good job. The important part here is to give the example on the task. So then you will need to also input with the same extractor. Actually, you can use different namings for the input and output. But the idea is that by giving this specific input and output extractor, the LLM will pick up much better the task.
That makes sense in this context for sure.
Mm-hmm. So in the particular case of system model, I would need to think about it, but definitely there's like some room for using few-shot learning.
Okay, that's a good general strategy to keep in mind, because indeed, while LLMs have kind of an astonishing amount of background knowledge, certain very particular tasks like writing system modeler code are probably beyond its ability. So teaching it using that demonstrated ability to learn with a small amount of information seems useful. And this is kind of an interesting practical question, I think, from Scott, who asks, you mentioned the importance of avoiding things like nesting something for infinitely many iterations in terms of cost. This should come up with ImageSynthesize, another LLM model, related things. So is there any plan to estimate a cost beforehand or allow a user to abort? Perhaps if the cost seems like it's going to be over a certain amount, something too memory constrained.
This is a
bit of a trickiness there.
This is a good question, which I don't have a specific answer right now. Right now, you have to be careful on how you kind of allow the calls to the LLM model. If your kind of code it contains like an infinite loop, it can be like problematic. I think the best thing is to also set up a threshold on the OpenAI side, so it doesn't burn too many dollars. I think this is something I saw on Twitter. Some people like running these auto GPTs and kind of I think they were like burning thousands of dollars in less than 1 hour. So this is not related to Wolfram, but that's something that can happen with this type of autonomous agents or autonomous ways of calling the API.
Yeah, that makes sense. That there's
in this case you're in the safe side if you're calling LLM function is only calling it once, or LLMExampleFunction. But of course, as soon as you put it into a table or a list or a map, you can call it multiple times.
Of course, yeah.
Yeah, that's an issue with any.
If you have worries on the cost, that's why I recommend you to use the default GPT 3.5 Turbo, which is much cheaper than GPT-4.
Yeah, makes sense. At a very, very rudimentary level, and you just mentioned, in under an hour, you could spend quite a bit of money if you, happen to make a bunch of calls. But at an extremely rudimentary level, you still can use a time constraint currently, which may help. But I think it's wiser to stick with, as you said, if you're using LLM function and you're just using that on an input, that's just going to be one query. So, there's no problem there. There's kind of a related question here, I think, that is more on the computational, or it's coming from the computational side than the cost side. So can the failure of an LLM API call to return, or I'm messing up the intonation there, but can the failure of an LLM API call to return a result be caught without crashing the computation?
Right. What I kind of recently used was the function. So I was repeating whether I was using until for repeating the like testing whether there was like a failure on my evaluation of the my calling of the LLM function or LLMExampleFunction, and keep trying it until it worked. Of course, this can also be problematic if it fails for some other reason in your code.
Right.
But in my case, was working well because I needed to automatically evaluate kind of hundreds of exercises from the Wolfram language introduction to the Wolfram language book. And in this way, I could avoid, I think right now, the OpenAI API give you errors from time to time, since there's like servers are like quite busy. From time to time, they will fail and they will not provide you an answer. It will give you an API error. So I was using until for like, in case it fails, to repeat the evaluation.
Okay, that makes some sense. I think we have time for just one or two more questions, probably just one, but we'll see. So Christopher notes, I found LLM example function has a bad habit of literally writing the string output into the result despite my admonishments. And I've definitely seen admonishments make a difference with these, but do you have any tips for how Christopher might avoid this? And maybe this is similar to the example before, where if you say, here's the type of input I have and I want the output to look like this without output.
Right.
That would help. But
so it helps with extra examples. In most of my examples, I was using a couple or 3 examples. But if you give a specific output format on what you want, in just like a few examples would be enough to pick up. All these examples I showed were like using the same kind of tricks, this few shot learning. I don't know which specific example. So for example, in this case, it was a super simple LLM example function, where in this case, I was asking for, give me the kind of, like the LLM figured out that I was trying to classify the sentence, whether they're like male or female. And it complained, it did not kind of answer with M or F. And so in this case, it generated the text.
Right.
So it depends on the task, how well determined is the task. But in this case, for example, I could also put here, I could do a third example. In this case, kind of, and then also like have a new example with like a case for that outlier, and this should be now just the kind of the output I want. Yeah.
Okay. And I think that's a good place to leave it given the time, but it's also a nice way to kind of lead into just a brief mention of what tomorrow's talk will be. Namely, tomorrow we'll have Bob Sanheinrich with us, who's development manager here at Wolfram Research, kind of the master of all things repositories, so function repository, courseware, Packlets, or now prompts. So Bob will be telling us about the prompt repository. It's under construction, as you can see, but this will kind of help you, learn how to construct prompts in order to feed an LLM a question in a reasonable way and kind of get these sorts of output that you're hoping for very, very broadly. So we'll talk more about this tomorrow, but thank you for today's presentation, Jofre. I think a lot of people found that very useful. We had tons of great questions and we had a lot of great answers there at the end. So thank you for the presentation and thank you everybody for attending. We'll see you tomorrow
Thank
at
you.
the same time.
Bye-bye.
Have a great rest of your day. Bye-bye.